The next concept that we're going to talk about is something called a function. Now, I spent a long time today looking for what I think is the best analogy for a function, and I came up with this. So are you familiar with the Dr. Seuss book about Sneetches? So the Sneetches book is really an allusion to things like racism. Basically, it's about there's these creatures called Sneetches, and some Sneetches have stars on their bellies, and some Sneetches don't have stars on their bellies. And basically, they become jealous of each other. At first, the Sneetches with the stars are very snooty and saying, we're the good ones, and anyone without a star means they're inferior. And basically, this guy with the green hat comes and invents this machine that can make it that even if you don't have a star, if you go into this machine, you can come out with a star and be like all the star beings. I do not want to focus right now on the morals of this book. I actually just want to focus on this machine. That's where I'm focusing on right now. So in this machine, we have clearly this in thing and this out thing, which I'll call the input and the output. The input into the machine are the Sneetches that do not have stars on their bellies. The output are the Sneetches with the stars on their bellies. It's pretty straightforward, right? Input, output. Functions are very much like this machine, except that they're blue. No, they're not blue. Or yellow. Let me show you what a function looks like. I'm going to make a machine that instead of putting in Sneetches, we're going to put in numbers. And the output is going to be the doubled version of that number. Meaning if the input is 2, the output is 4. If the input is 4, the output is 8. If the input is 16, the output is 32. And that's the extent of my math. I'm not going to go higher than that. That's risky. So let me invent that machine. And again, this machine is called a function. I'm using the special, there's a lot of new keywords at play here. I'll walk through all of it, but let me just get it out. The name of my machine is the double machine. It is a doubler. If it takes a number in, it produces as its output the doubled version of that number. It is going, again, don't worry about getting every detail right now. There's a lot of stuff going on. I will review this, but this here, after the def means we're about to create a function. The name of the function is double machine. It is going to accept a variable called input variable. You'll see. Hold on. End. That is the end of the function. You got him?
Yeah.
Okay. Output is input variable times 2. Return output. I know none of this makes any sense right now. Okay. Let me walk through it like this. Let me start with line 6. Line 6, this is how we use the double machine. We say double machine 10. That means to say that we are putting in as the input into this machine. Instead of putting a Sneetch, we're putting in the number 10. The output that we hope to get out of this double machine is a 20, because that's the doubled version of 10. If we left it without the P, Ruby would run it but wouldn't do anything with it. So we want to print out the output of double machine. If we run it, we get 20. Let me change that. Okay. If we run it, we get 20. So I'm starting with the usage of this function. So we're turning on this function by calling its name, double machine, and we're throwing into the input the number 10 instead of a Sneetch. Okay? This is the actual machine under the hood. But before I get to how this machine works, because look, the machine is pretty complicated looking. There's steam and wires. So my machine is also pretty complicated. But right now I want to focus on the usage of the machine. I use the machine by calling its name and having parentheses after it in which I throw in the input. When I run this and I print out whatever comes out of here, I get 20. Because this is a double machine. It takes in my input and gives me as output the doubled version of it. So if the input is 10, the output is 20. If I put in the input of 2, the machine will spit out 4. So that's the beauty. It's hard to appreciate it yet, but the beauty of functions, the beauty of these machines, is that they work no matter what input I put in. I can throw in any input, and I'll get a different type of output. So it's flexible. Okay. Now let's talk about the actual machine. So there are 2 new keywords introduced here. Def, which is short for define, although you can't write define. Ruby won't accept it. You actually have to say def. And another keyword called return. Everything else here is actually a variable. So output is a variable name. And this, I think, is the #1 trickiest concept, most confusing concept about functions, is this person here. It's not a person. Until now, we've introduced one way. This is terrible with the light. We've introduced one way of setting a variable, right? X equals 5. Sorry, Fred equals 4, right? It's always something equals a number. This introduces, a second way of setting a variable, okay, that we've never seen before. And the way that works, I am now descending from the table. The way that works is through this. When I call the machine by calling its name and putting in a 2, it now becomes this variable, meaning whenever I now say input variable, that is a nickname for 2. If I throw in a 10, input variable is now a nickname for 10. It's as if I wrote this line of code. However, I don't write this line of code because the whole idea here is that I want this to be flexible, meaning I can't write input variable as 10 because I want to make it that this machine works even with a 5. So if I put a 5 into the machine, this input variable really becomes 5. I could have called this Fred.
So basically, the second you write anything in there,
it
sets up whatever term as a separate variable.
Yes.
Or whatever the hell you feel.
That's one way of saying it, yes. So this is a new way of setting a variable. Until now, we've only seen this way, input variable equals 5. But this is a second way where we have it as part of our invention, as part of our machine. This is the name of a variable, but it gets set when we throw in input into it. Then it gets matched up with this. So now whenever we refer to input variable in our machine, in the internals of our machine, it refers to the input. It refers to that 5. So if we say double machine 5, that means anywhere in our code within the function where we mention input variable, we're referring to a 5. If I threw in a 7, that means input variable is now a nickname for 7. And anywhere that we mention input variable, like we do here on line 3, it's referring to the 7. It's referring to whatever we input into the machine. The way functions work are that functions know that whatever you throw in the parentheses, when you actually use the function, whatever you throw in there is going to be set to this variable name that we put in the parentheses here. Meaning, short answer is just that's the way Ruby works. That's the way functions work. Now again, if I put Fred here, Ruby doesn't care what it says here. This is a variable name. Just like I can name any variable, any name I choose. So if I name this Fred, then throughout the duration of this function, whenever I refer to the variable named Fred, I'm referring to the input. Say, which in this case is 7. I'm going to rename this variable, again, called input variable. It's as if we said over here input variable is 7. However, we didn't. We don't need to. This is a new way of setting a variable. So now let's follow the code the rest of the way through. We're now making up a new variable. I could have called this Lisa, but I called it output. Output is the name of a new variable, and this I'm setting in the traditional way of variables. I'm just saying output equals something. Output equals input variable times 2. So if the input variable is 7, output is now 7 times 2, which is 14. If the input variable is 16, then the output is now input variable 16 times 2, which is 32. So now this output variable, if I were tracking it in comments here, so let's say I threw in a 16, output is now 32. And that brings us to line 3, which is return. Return is a special word in Ruby that is reserved for functions that basically is this. It's saying, what should the function spit out on the other end? So function is a special keyword in Ruby. So a function is a machine where it takes an input over here. So this input variable is sort of like the equivalent of this in part of the machine. And the return is the output of the machine. In the internals of the machine, so I have no idea what's going on in the internals of this machine, the Sneetch machine. But here, the internals are, we take your input, we double it, and assign it to a new variable called output, and we return that output. I try not to confuse you, but I could have done this on one line. Not sure if this is more or less confusing. I could just simply return. So output was just a variable that I made up. I don't have to make a variable. I could just say return input variable times 2. Again, take it from the top. I am inputting a 16 into this machine. I turn on the machine simply by calling its name. Lines 1 through 4 are the machine itself. Line 6 is where I actually use the machine. 1 through 4 is the blueprints of this machine. Line 6 is where I turn it on and throw something in. And then I print its result with the P. So when I activate a machine simply by calling its name and throwing in an input. The input is received by this variable, which I've named input variable. That's just the name I gave it. Could have named it Fred. This is a new way of setting a variable. Because I never said input variable equals 16 anywhere. This just happens when you throw a number into a function like that. Now, whenever we say input variable within this function, that refers to the 16, because that's what we input. On line 2, we say output equals input variable times 2. So output is 16, in this example, times 2, which is 32. We then return the 32, and that is what's output by the machine. So when we run this, we basically say print double machine 16. That goes, we throw the 16 in, it makes a lot of noise, steam comes out, whistles and bells, and then the machine returns the output, which is 32, and we print that output over here, and that's why we see 32 when we run this program. How does Ruby actually process this? So when Ruby processes this program from top down, it starts on line 1. The thing here is, though, when Ruby sees def, it's saying, OK, I'm seeing here a description for the blueprints of a machine. But I don't have to do anything. I'm just going to register in my mind, OK, there's this machine called double machine. This is how it works. Noted. Keep that in my memory. Then we move on. We get to line 6. That's where we actually activate and use the double machine. So Ruby is going top down. It's just that we don't see Ruby doing anything as it proceeds from lines 1 through 4. But Ruby is doing something. It's saying, OK, I am registering in my mind there is now this thing called double machine that does this. Does that make sense? Great question. Other questions? Again, the more you work with this, which I will have you do a lot of tonight, the more you'll get used to it. There's nothing inherently complicated. It's just sort of like, I mean, this isn't necessarily, this might be complicated. I don't know what's going on here. But It's basically showing you what's connected to what, which wire is connected to what.
Hey Jay,
Yeah. Hey, Cassie.
I have a quick question.
Yeah.
What does the return do if it works with or without it?
Yeah, the return is necessary in the function because that, whatever you say, whatever you are returning, that is what gets spit out of the machine.
So if you commented that line out and ran it, does it still print with the 16 in there? Or does it still
Yes, but only because of something I'm not revealing to all of you yet.
Okay.
But just take it for granted right now. So right now I'm lying to you and saying, no, it won't work. You need the return.
Okay.
But I'm lying. You don't need the return, but that's only because of an exception, of a special rule, which will confuse everyone. So I'm ignoring it now. Let's assume you absolutely need the return for the function to work. If you don't have a return, nothing will get output from the machine.
So if you take the whole function and swap it underneath.
So you mean if I put this on top?
Yep. I mean,
So Kale has a good question.
that's
What
it's gonna
happens if I do that? So very much talking about top down, when Ruby runs this program, and Ruby starts on line 1, and it says, okay, let's activate this thing called double machine. Ruby says, error on line 1, undefined method double machine. I don't know what that is because it hasn't gotten to it yet. So I actually have to put this line below. So Ruby first registers in its mind what the double machine is, and then I can use it because of Ruby's process of processing each line of code top down. Great point.